Okay. Alright, so in this problem, we're finding the voltage through R4, right?
Yeah.
Okay, voltage drop across R4. Okay, start out the same way. We draw our currents. So, my markers everywhere. Alright, we'll say I1's going like that, I2's going like that, and I3 is going like that. Okay, so what's our first equation?
I1 equals I2 plus I3.
Yep. Off with I1 equals I2 plus I3. Okay. Next, we'll draw our little arrows for the batteries. Remember, they always go toward the large end. So for the, you guys want to start on the top or the bottom?
Bottom.
Alright, so the bottom loop, I'll draw it the way I always draw it. We'll start with this battery down there. Is that in the same direction or the opposite direction as the loop I drew? Same. I'm going to say 0 equals 54 volts. It's positive because it's in the same direction for voltage. One thing I want to make sure you guys understand is that the currents don't have anything to do with the batteries. So completely ignore the currents when you're looking at like the direction of the batteries. Everything is compared to the loop here. So like when you're doing the resistors, you compare the current to the loop. When you're doing the batteries, you compare the little area you drew for the batteries to the loop. Does that make sense? Okay. Next up here is R2. What current's going through R2?
18 plus 18 times R3.
Okay.
That's correct.
I3.
That's what I said. Good job.
So it's
R3.
Okay. So we have I3 is going through R2. So it's going to be 18 ohms in I3. And is it the same direction or opposite direction? Opposite. So we add the resistor. So plus I3 times 18 ohms. Alright, next up is V2. Same direction or opposite? Opposite. So what do we do? Subtract. So we do minus 39 volts. Then R3. Same direction or opposite? Opposite since it's I1. So it's going to be plus I1 times 3. 20 ohms. Does that make sense to everybody? And we have one more to do still.
Yeah.
What's R1 going to be? Is it what current's going through that one?
I3.
I3. And is I3 the same direction or the opposite direction as the loop?
Opposite.
Opposite, so what are we going to do?
Add it.
Add it. So you're going to say plus I3 times 19.
Yeah.
Hopefully that's visible on the camera there. I'm gonna look at the camera. Yes, that'll be okay. Alright. I'm going to go through and solve this real quick just to make it sure it's underneath there. So we're going to solve it for I3 in terms of I1. I'm going to bring both I want I3 to be positive, so I'm going to leave it on this side and bring everything else to the other side. What is 54 minus 39?
First, no, 15, sorry. I was doing something else.
There's going to be 15. We're going to
I
have,
added 18 and 19.
so on this side it's going to be negative 15 when we, and we're going to bring over I1, so it's going to be minus I1 times 20 ohms equals 18 plus 19 is I3 times 37 ohms. Everybody with me so far on those? Okay. Now we divide everything by 37. So we get I3 equals, what's 15 divided by 37?
Negative 0.41.
And what's 20 divided by 37?
0.54.
Alright, so there's our equation for I3. Any questions on that one? Alright, can I erase this? I'm going to do the top loop. And I'll draw it like I normally draw it, around like that. So start with that battery right there. Is it the same direction or opposite for V2? Same. So the arrow is pointing that way in the top loop, and the loop we drew is pointing the same way. Does everybody understand that? So it's going to be 0 equals, what's V2? 39 volts. This one, V3, same direction or opposite? Opposite. So minus 38 volts. R4, is that the same direction or opposite? It is same direction, so we subtract it. So it's going to be minus I2 times 20 ohms. And R3, what current's going through that one? I1, and is that the same direction or opposite direction as the loop? Same. So we subtract, so minus I1 times 20 ohms. Any questions about that? So now we're gonna, again, solve for I2 in terms of I1. Bring I2 over to this side, so we get I2 times 20 ohms equals 1 volt minus I1 times 20 ohms. Divide everything by 20, we get I2 equals 0.05 minus I1, since 20 divided by 20 is 1. Any questions on that one? How are you guys feeling about this? Fantastic.
Wait, Mr. Guy, I have a question.
Yes.
Okay, so why on the top is V2? So it's going the same way as the loop on the top, but yet it's going opposite on the loop on the bottom.
Okay, so V2 here.
Yeah.
So you see how V2 is on the top? It's like if you drew the
Oh, so
bottom.
you have to follow where it is on the loop. That's
Yeah.
where. Oh, okay. That makes sense then.
So the V2 is kind of on the top of the loop in the bottom part, and it's on the bottom of the loop
Okay.
at the top.
Okay,
That
makes
makes sense?
Yeah.
Alright. So now we're going to substitute in. For this equation we have I1 equals, what did I2 become?
0.05 minus I1.
And what was I3?
Negative 0.41 minus 0.54 I1.
So I bring all the I1s over, we get 2.54 I1 equals that 0.36
Yes.
And what does I1 equal?
Wouldn't it be a negative?
Yeah.
Oh, thank you. Negative 0.36.
That equals negative 0.14. Yes.
Negative 0.14?
Yeah.
Okay. This is just asking us about R4. Do we need to find I3 at all?
Nope.
Nope. So we're going to find I2, multiply it by I4 to get the voltage across, or multiply it by R4 to get the voltage across R4. So I2 equals 0.05 minus I1. We get I2 equals 0.19 amps. Now to get the voltage across 4, we just do, since I2 is going through it, we just do I2 times R4. We get 0.19, that's 20 ohms, equals 3.8 volts is our answer. Kyle? Yes. Okay. Any other questions on that one? Alright, do you guys want to do number 3 together as well with the branch at the top?
Yeah.
Okay.
Wait, which one?
Yes, Michael?
So for tomorrow, do we get to have like a little nooker or something with like with the arrows and all that?
The arrows?
Yeah, so I would like for
Like,
if
so
they're all the
say-
same or opposite.
If you want to write, have a note card that says like the same and opposite stuff, that's fine.
Okay.
So you remember it. Okay, so this time we're looking for the current and voltage through R4. It's slightly more complicated since this is in parallel. We still can start off the same way though. Draw our little arrows for the batteries. And then we have I1, I2, and I3. So we can start off with the same equation here. I1 equals I2 plus I3. Alright, so now we start off at the bottom. Go around like that. We do 0 equals. Start with this battery. Same direction or opposite? Same. So do we add or subtract? Add. So we end up with 67 volts. R1. Same direction or opposite? Opposite, and it's a resistor, so we add it. So it's going to be plus I3 times 23 ohms. V2, same direction or opposite? Same. So what do we do? Add it. So it's going to be plus 64 volts.
Isn't it the opposite direction?
No, battery's pointing that way, the loop at the top is pointing that way as well. Okay, and last one, R2. What current's going through R2? I1 is at the same direction or the opposite direction as our loop? Opposite. So that's going to be plus I1 times 23 ohms. Any questions about any of the signs or any of those terms? Okay, now we're going to do solve it for I3 in terms of I1. So we end up with negative 131 volts on this side. So we do 67 plus 64 equals 131 to bring it to the other side. Minus I1 times 23 ohms equals I3 times 23 ohms. Any questions about that? So we'll solve for I3. I3 equals negative, what's 131 divided by 23?
Negative 5.7.
Negative 5.7 minus 23 divided by 23 is just I1. Okay, so there's our bottom loop.
Whoa.
Good job, Brian. Can I erase this?
Negative 5.7.
Okay, so for the top loop here, run in the same direction. First thing we want to do is simplify R3 and R4. So it's going to be 1 over R3 over 4 is equal to 1 over 6 ohms plus 1 over 22 ohms. So what's R3 4 equal?
4.71.
Okay, so that whole thing we're just going to treat it like one 4.71 ohm resistor. So we'll start at 0 equals, is V2 the same direction or the opposite direction now?
It's the opposite.
Opposite. So it's going to be negative 64 volts. What current's going through R34 up there? I2 is at the same direction or opposite?
Same.
Same. So what do we do?
Subtract.
Subtract. So we do minus I2 times 4.71 amps ohms. And last one, R2, what current's going through that one?
I1.
I1, same direction or opposite?
Opposite. Same.
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 Oh,
You're
I1.
looking at the battery.
Sorry, I was looking at battery.
So it's going to be I1 times 23. So we'll solve that one for I2 in terms of I1. I2 times 4.71 ohms equals negative 64 volts minus I1, 23 ohms. And I2 equals, what's 64 divided by 4.71?
13.5.
13.5 what?
Right.
Shouldn't it be negative?
Yes.
Yeah.
Thank you. And then 4.71, 23 divided by 4.71,
4.8.
4.88 is I1. Everybody with me still? Any questions on any of the terms up there or anything like that? Can I erase this top part? Okay, so now I substitute it into the I equation here. So we get I1 equals, what was I2?
Negative 13.59 minus 4.88 I1.
And what was I3?
Negative 5.7 minus I1.
So bring all the I1s over to this side, we get 6.88 I1 equals 5.7 plus 13.59 is 19.29.
Negative one.
Thank you. You're getting the negatives. Alright, so we divide that out. What do we get for I1?
Negative 2.8.
Negative 2.8 amps. That means we drew our line for I1 the wrong way. And then, again, do we need to find I3 at all? Nope. We just find I2 is equal to negative 13.59 minus 4.88 I1. What's I2 equal? .08. Ends up being a really small current. That's not terribly surprising, but
Even though we got I1 as a negative, when we plug it into the other equations, you put it as positive.
still has to be negative.
Still negative.
When you if you find out one is negative, you still plug it into the other equations as negative. So I would suggest never dropping the negatives because when you're testing quizzes, I'm just gonna look for absolute values anyway. Okay, so now we have the current going through this whole thing right here. That means this whole piece is 0.08 amps. So how do we find the voltage through it? V equals IR. So we're going to say the voltage through 3 and 4, since they're in parallel, they're the same, is equal to I2 times R 3 and 4. So V 3 and 4 equals 0.08 amps times 4.71 ohms. So what's the voltage through 3 and 4? 0.35.
No, 0.38.
Yeah, 0.38.
I had started with 0.74, sorry.
That's okay.
0.38 volts. Yes, Brian.
If we count I2 as like negative 0.08, would we use positive 0.08 and the V equals IR?
Yeah, you still, like, when you do the V equals IR equation, you want to use the positive. Because the voltage drop doesn't matter for direction. Alright, so now, to find the current through I4, since these two are in parallel, there's a 0.38 or 0.38 volts through both. So to find the current through I4, we take, actually let me draw it like this. So the voltage through 4 is, we take the voltage through 4, so I4 times R4, and since these two are in parallel, there's 0.38 volts through both. So we're going to do 0.38 volts equals I4, which is what we're looking for, times 22 ohms. And I4 equals something.
0.02.
0.02. Those are our two answers. Any questions about that one? Alright. Why don't you guys try doing number 2 on there?